Alright, so in this video I'm going to show you how to answer this question on moments. So we've got a uniform horizontal bar of mass 5 kilograms, has length 30 centimeters and rests on two vertical supports, 10 centimeters and 22 centimeters from its left-hand end. Find the magnitude of the reaction force at each of the supports. Okay, so like any mechanics question, we want to start by drawing a diagram. So let's put our horizontal bar there, and we've got two vertical supports. So let's put one here, we'll call that one A, and that's 10 centimeters from the left-hand end. Then we've got another one, so let's call this B over here, and that's 22 centimeters from the left-hand end. So let's say this distance is 12 centimeters, so that adds up to 22 from the left-hand end, which means since the total length was 30, we've got 8 centimeters left over here. Okay, now these two vertical supports are going to mean we've got two reaction forces, so let's name that R1 and R2. And we're also going to have the weight of the bar. Now the mass is 5 kilograms, so the weight will be 5g. Since it tells us it's a uniform bar, the weight will act directly in the middle. So that's going to be somewhere here. So we can label that as 5g. And we know that this is 15 centimeters because that's halfway along the bar. Now we want to find the magnitude of these two reaction forces. So to do that, we can take moments. Now we want to eliminate one of them to make our calculations easier. And let's start with eliminating R1. So if we take moments about A, we will eliminate R1 because R1 will have a moment of 0 as it's acting directly through A. So we're going to take moments about A. And I need to say what direction am I going to define as positive. So I'm just going to say clockwise with an arrow there. Now 5g is going to give a clockwise moment because if we were to hold it at A, that's going to go down that way, clockwise. So we have the force, 5g, times the distance. Now the distance is going to be 5 centimeters if that's 10. It's 15 centimeters along altogether. That's going to be 5 centimeters, so 0.05. Just changing our distances into meters to keep our units nice. Then the R2 is going to go anti-clockwise, so that's going to be a negative moment here. And we're going to have R2 times, and the distance from A is 12 centimeters, so 0.12. Now it's not moving, so that's going to equal 0. So now I just need to solve this equation for R2. So 5g times 0.05 equals R2 times 0.12, and I'll just be able to solve that easily on my calculator. I'm going to use 9.8 for g, and I'm going to end up with R2 equals 20.4 newtons. Okay, it's a force, so that's going to be newtons. Right, now to find out what R1 is, I could swap over to B and take moments about that, but it's actually even easier than that. This is a situation in equilibrium. We know that the resultant force in any direction is going to be 0, so we can actually just resolve forces vertically. And we know that R1 plus R2 should equal 5g. Now we already know R2, so R1 is 5g minus 20.4, which is 28.6 newtons. Okay, and there we have the answers for the reaction force at each support.